So, it's a small question. I wanted to know if, so what it is right now is you verify that light takes the shortest path and the shortest path is indeed much closer to being a straight line between the 2 points, right?
Well, a straight line?
You verified with numbers that light will take the shortest path.
Yes.
Can you prove it without numbers for a general case?
For any general case, I guess so. You could say, I need some more space here. For any general number, I guess we could say, here we have,
Excuse me.
yeah.
What? Can I erase that side?
Yeah, sure. Okay. So for any particular case, I guess we could say this, let's call it x. Let's call this part x1 and this part x2. And I don't know, this part is a constant. So I guess we can call it some number n. So when we're talking about this, we have the square root of n squared plus x1 squared times 2. Well, no, we have n squared plus x1 squared plus the square root of n squared plus x2 squared. So in a case where x1 is less than x2, or in a case where x1 is greater than x2, versus a case where we have 2 times n squared plus 2x1 squared. How can we prove that this is going to be less than, say, a place where x1 is less than x2? Okay, plus root n squared plus x2 squared. Okay, so, and here we're assuming this x1 is less than, how do I don't know, let's call this y, for example. So, how can we prove that this is less than this, where y is equal to x1 plus x2 over 2? Well, I guess we could work around it with some very weird algebra. So, but it would eventually come out to something like this. So plus x1 plus x2 squared over 2 less than n squared plus x1 squared plus root n squared plus x2 squared. It should be pretty easy to prove that these two are, one is lesser than the other, but I guess I'll still have to try just to prove it. Okay, so let's square both sides. 2 times n squared plus x1 plus x2 squared over 2 is less than, this side is going to be n squared plus x1 squared plus, oh boy, we have to do n squared plus x1 squared. This is not very easy to work with. But n to the 4th plus x squared squared n squared plus x1 squared n squared plus x1 squared x2 squared. So that's not going to be easy to figure out. n4 plus x squared n2 squared plus x1 squared n squared plus x1 squared x2 squared. That is not something I want to work with right now. Okay, that is not good. That is very not good. Because then it would have to mean, if,
Excuse me.
yes?
Do you use Euclid's law of triangles?
Euclid's law of triangle to do what?
But can't we just say that the sum of two sides of a triangle is greater than the third side always?
The sum of two sides of a triangle is greater than the third side always. How can we use that to do this? X1 plus, okay. How is that going to be applicable here? Because if I talk about, I don't know, this case, x1, x2, and we can say this is hypotenuse 1, hypotenuse 2. Obviously, hypotenuse 1 has to be less than n plus x1. Hypotenuse 2 has to be less than n plus x2. But then, how does that make a difference when we have...
Isaac, you have to go to the lecture too.
Yeah.
We are falling behind the schedule.
I don't like having an incomplete question.
That's fine.
I'm so sorry.